when we actually talk about the ear, okay, there's a very small part of the ear that's actually on the outside of the body. The rest of the ear is actually inside the body. And a portion of it is considered to be inside the body, but actually not inside the skull. Okay, so we're going to actually differentiate between the outer ear, the middle ear, and the inner ear. And we're going to look at how we actually process sound. So when we actually start talking about the ear, the outer part that everybody sees is referred to as the funnel. And that's exactly what it actually does. It basically traps sound into the actual ear. Okay, so sound comes in and gets funneled inside the actual ear into what's collectively known as the auditory canal. Now, the auditory canal might have a few little actual hairs in it, nothing major. Okay, it's where earwax gets deposited. And the last part of the inner, or the outer ear, I should say, is something known as the actual eardrum. And it's referred to as a drum because it does exactly that. It behaves the exact same way that a drum behaves. In that when it gets a sound wave, it vibrates depending on the actual sound wave it's receiving. So these three parts, the pinnae, the auditory canal, and the eardrum, are collectively referred to as the outer ear. Even though some of them are kind of inside your head a little bit, they are referred to as the outer ear. Okay, so that's the outer part of your hearing. And then here's where it gets kind of interesting. Okay, I'm going to do the next section in a different color, just so it actually stands out. So you'll notice that the next section of the ear is a really tiny one. Okay, it actually is just a projection of the actual auditory canal, but it is no longer considered part of the outer ear because it's on the inside of the heads of the actual tympanic membrane of the eardrum. Okay, and this is where the three smallest bones in your body reside. Here's where the chain reaction starts to occur. The inner ear is actually quite a small part the middle ear is actually quite a small part of the auditory system, but it's a super important part because this is where we start to take invisible sound waves, because right now I'm speaking to you and I'm actually emitting or transmitting, I should say, auditory energy towards you. And that auditory energy is invisible to you. But once it enters your ear and actually hits the eardrum, depending on the volume and the pitch of that sound, it's going to translate into a physical vibration of the eardrum. So if I'm speaking to you at this level, okay, first of all, I'm going to have a certain amplitude. This would have a lower amplitude than if I spoke to you like this. I have the exact same pitch, but a much higher amplitude. And here I've got an exact same pitch again. The kind of note that my voice is hitting remains the same, but my amplitude is much lower. So the actual wavelength here is the note at which the sound is coming in. And that's going to create a wavelength in the vibration of your actual eardrum. And because your actual hammer is resting on your eardrum, as soon as the eardrum starts to vibrate, the hammer that's sitting on it will also start to vibrate. And guess what? The anvil that's touching the hammer will also start to vibrate. And finally, the stirrup, the smallest bone in the human body, will also start to vibrate. Okay, so this is where we go from having an invisible sound wave to a visible vibration. Okay? Okay, one thing that has absolutely nothing to do with the auditory system is the fact that in your middle ear, you actually have these tubes that drain into the bottom of your throat. These are known as your eustachian tubes. As a child, perhaps if you were really prone to earaches, it might have been an issue with these tubes, because if you've ever gone swimming and you've had water in your ear, sometimes you shake your head and the water comes out, but sometimes the water's there and then next thing you know, you don't have that sensation of water in your ear anymore. And that's because this is a drain towards your actual throat. Oops, there's an O in there. And interestingly enough, your nasal cavity and your ears all drain into your actual pharynx, your throat. Okay, so when we talk about an ear, nose, and throat specialist, that's because they're all actually interrelated. And sometimes having strep throat can lead to having earaches or a sinus infection. Okay, because there's tubes, there's little roadways that actually link all of these places. All right, now this is referred to as your eustachian tubes. And eustachian tubes help drain, okay? They help drain the actual fluid from your middle ear, but they have absolutely nothing to do with hearing. Zero, zip, zilch. Now, when we get into this next section of the ear, okay, known as the inner ear, this is where we actually take that vibration, that physical vibration that we're creating, and we turn it into a nerve impulse. Okay? So we're not done our chain reaction yet. What has to end up happening here is you'll notice that there's actually this empty space here. And I'm just going to erase some of these words so that we can actually illustrate this. Now, this empty chamber, okay, is now filled with fluid, like water-like fluid, but it's not pure water. It's actually very close to tears and interstitial fluid, like extracellular fluid, very similar. Okay, and this chamber, all right, this chamber here is kind of like this closed ballroom, and then it actually links to a bone that basically, okay, looks like a ginormous swirl. Okay, it almost looks like a snail shell. All right, so this inner chamber here is known as your vestibule. And your vestibule is exactly that. It's a hollow chamber filled with fluid. So if a bone, like your stirrup here, is vibrating and whacking, okay, a fluid-filled, basically, chamber, what's going to happen to the fluid inside the chamber? What will happen to it? If I have a glass of water and I start whacking the outside of my glass, what happens to the water inside it? It will start to vibrate at exactly the same rate that all three of those little bones were vibrating, which is exactly the same rate that the eardrum was vibrating. Okay? So again, we're still transmitting from one place to another. It's like we're playing hot potato. We're passing the potato from one bone to another. Okay, so the vestibule is filled with actual fluid, nice and liquidy here. Okay, and that vibration and that fluid actually goes into the last section here of your auditory chain reaction. And this is known as your cochlea. Okay, so this spirally kind of snail shell bone is known as your cochlea. And interestingly enough, the cochlea is filled with fluid as well, but there are small little hairs on the inside, microscopic little hairs on the inside of the cochlea. And it's these actual hairs, okay, which are actually embedded along the bone here. And it keeps going all the way in, okay, and linking the actual cochlea. All right, so here's where it gets kind of interesting. Linking the vestibule here and the cochlea are your auditory nerves. So these are the nerves that are going to transmit your actual stimulus. And notice how the little hairs that I've drawn in the cochlea are green. Because just like your rods and cones, the sensory receptors for light, the little sensory receptors for actual sound are these little hairs that basically stand up and they're free floating in the fluid. And when the fluid starts to shake, those little hairs actually shake at the exact same frequency. And it's that shaking message that's going to get sent down the auditory canal, and it's going to get processed as, okay, the frequency was a little bit slower, so it must be a lower sound. Or the frequency was really fast, so it's a high-pitched sound. Okay, and the amplitude of the wave meant the volume. Okay? So those are the little hairs inside the actual cochlea. So here's your cochlea. And it's the cochlea that is the site of that stimulus being developed. It's the little hairs inside the cochlea. Okay? Now, notice how there's a nice big chamber up here. There's still some vacant spaces. Do you see all this space up here? Okay, here's another space that has absolutely nothing to do with hearing, but is super important, and it's found in the inner ear. Okay, here we have actually this set of tubes, these bony tubes, basically, that go around and they're filled with fluid. These are known as your semicircular canals. Okay, they are actually filled with fluid. So there's fluid inside these, just like there's fluid in the actual vestibule. And this has nothing to do with hearing, but it has everything to do with your center of gravity, your balance. Because this fluid, okay, in your semicircular canals, acts exactly like a level does in construction. When you have a level in construction, okay, a level is a straight bar, and inside there's a little disc of liquid, and there's a little ball of air in it. And if you want to know if you're putting a couple nails up or if you're putting a shelf up and you want them to be equal to one another, a shelf's not going to work if one nail is put down here and the other one's put up there. Okay, unless you don't want anything to stay on your shelf. If you want it to act as a ramp to launch things off of, awesome. But a lot of times in construction, we use levels to make sure that things are on the same plane. So levels balance things out. That's exactly what your auditory canals do. Okay, or your semicircular canals. Okay? So all of this is part of the inner ear. And it's in the inner ear that sound actually goes from a physical vibration to a sensory, okay, to a sensory stimulus here. These are sensory receptors. And this is your auditory canal. So, just to go over it again, all right, a sound will actually enter the pinnae out here. So sound will come in, it will hit the eardrum, and it will cause that same vibration to occur through the hammer, the anvil, and the stirrup, which will whack against the bone of the vestibule, and it will cause all the liquid in the vestibule to vibrate, which will then get transmitted to the liquid in the cochlea. And those little hairs, little green hairs there, the sensory receptors in the cochlea will vibrate at exactly the same rate, and that will get transformed into an auditory stimulus, which your brain has evolved to be able to process.